Welcome to the night class. This is Coach Knight. We're going to start chapter 11 today. Chapter 11 in our algebra class is basically statistics. Okay, statistics you'll hear a lot here because we have an election a week from tomorrow. You'll hear a lot about predictions and within a percent error or whatever. All that is statistics. All that when they take a sample of groups of people and they basically use that to project how the election will come out.
So that's how you base this in the real life?
It is, yes. This stuff is used more in real life than a lot of the other stuff that we've done. Okay?
But it can't be advised to people like Southern Mississippi, right?
So, correct.
It's hot in here.
Example 1 says represent and interpret data in a dot plot. So a dot plot is exactly what it sounds like. It's when you plot some numbers just using dots. Okay? It's very simple. It tells you how many of each value we had. So it says Manuel buys or plans to buy a new car with the gas mileage shown. What's the gas mileage shown? 26 miles per gallon. That's not bad, okay? Especially in the city. To determine if the gas mileage of this car is good, he gathers data on the estimated city driving fuel efficiency in miles per gallon of several other cars. How does the fuel efficiency of the car he wants to buy compare to the fuel efficiency of the other cars he researched? So here are the other cars he researched. One had 25, 29, 45, 26, 26, so on and so forth.
Nobody's getting 45 in the city. Come on.
Some people do.
Who? Like a Prius?
Exactly. Okay.
You gave up your life.
Hold on to that. Hold on to that. All right. So, it says we're going to use this information to see how it happens. So we're going to make a dot plot out of the values. There is our dot plot. I know you can't see it because I got to scroll down. There it is. Okay. So how many of the cars got 25 miles per gallon? One. How many got 26?
Four.
4 of them. How many got 27? 2.
4. 1.
All right. Some of this stuff you should already know or at least remember. What would that be considered?
Outlier.
Very good. That is called an outlier. Okay. That's not common, right? That's the one that's like it's either way a lot more or way a lot less than normal. Okay? So what was the car he was looking to get? How many gallons? 26. So, is that, about close? Yeah, it's in, according to this dot plot, most cars get between what and what? 26 and 28. Okay? Now, here's where me and the book kind of differ, because if I hit next, and it tells you to interpret it, it says between 25 and 28. Okay? That's a little thing, all right? I'm not really sure why they're picking 25, because there's only one that had 25, but if you had said 26 through 28, we would be okay, because that's what I would have said. Okay? Is everybody understanding how to do that? And how to make the dot plot. Everybody's good? Again, dot plots are useful to look at exactly how many of each type we have. Okay? Everybody good? It says use the dot plot to interpret the data. The dot plot shows that most of the values are clustered between, like I said, I would have said 26 and 28. They said 25 and 28. Everybody good on that? Easy peasy. Our next one. We get to try it. It says, in the dot plot of Manuel's fuel efficiency data, what might account for the outlier? So, we were just talking about this, Preston. That's why I said, hold that thought. What could account for that outlier? What would cause a car to get 45 miles to the gallon?
They drive slow.
It drives slow. That would work. What else?
They give a birth. You never sure you go fast.
You go fast if you give birth. What he said it, you might be driving a what? A Prius, a hybrid, or they also make what kind of cars now? Electric cars, okay, might be a Tesla or something. So anyway, any of those answers would be okay. Okay. What else gets really good gas mileage? Y'all might not even know this. No, absolutely not. Motorcycles, believe it or not, get pretty good gas mileage. All right. When they're tiny, yes. All right, our next one. Example 2. Y'all listen. Example 2, we're going to use a histogram. So just another type of graph chart, okay? So the first one was a dot plot. This is a histogram. Does it have anything with history to do with it? No. When the first time I saw it, I was like, histogram? What's it like? No. Has nothing to do with history, okay? Shh, class, please pay attention to me. Thank you. All right. So, histograms. These are when you take, like, a certain, I'm trying to think of the word, like 0 to 4, and then 5 to, thank you, a certain range of answers is when you're going to use a histogram, okay? So, it says a marketing team is about to launch a campaign for a new product that is targeted at adults aged 25 to 34 years. The team is researching the age range of viewers of a certain TV show to decide whether to advertise during the show. The data shows the ages of a random sample of 30 viewers of the show. Based on the findings, should the marketing team launch their campaign during this particular show? So, I know you haven't realized this. Advertisers pick which shows to advertise on, right?
Teachers and students, just a quick reminder that the yearbook is taking pictures in the foyer by the cafeteria. They said just stop by if you still want to just have your picture made, but if you want the picture printed, it'll be $5. And they will change it each day to match the theme.
Okay, so what does that mean? That means if I'm watching, let's say, a home improvement show, okay, Hometown or whatever, you know, whatever those shows are on HGTV, what might be an advertisement I might see? Lowe's, Home Depot, okay, Ace, hardware stores.
When you watch HGTV, Lowe's comes on all the time.
That's why, because if you're watching that, chances are you're going to see a project you want to do, and what do you need to do if you need a project? You got to go buy supplies, and where do they want you to buy it from? Lowe's. Does that make sense? Okay. If you're seeing, I don't know, if you're watching sports, okay, you'll see a lot of food advertisements, because what are you doing a lot of times when you're watching sports? You're eating, okay? So if you're watching Saturday morning cartoons, you see a lot of advertisements for toys, because the kids watching the TV show, they see the advertisements for the toy, and now all of a sudden they need this new toy, okay?
You know when you talk about something and then like the next day you get an ad
Right.
about it? That's a little freaky.
Yes, it is. All right. So we are here. I'm going to hit play because it kind of, I say I'm going to hit play. It is a video. Well, I say it's a video. Here we go.
Just a picture.
It's not. Why is it not? It's not working.
Oh no, it sounds like you're gonna have to explain it. I'm looking forward to this video so much.
It won't play.
It's gonna be
This is
so
terrible.
It says connect. It says turn the guy say
Where does it say connection here?
slide up a little bit more. Oh, it says common error, not right on. Good job, Brandon.
I mean, to be fair, it's pretty close.
It is pretty close. It's a common connection error.
That's why it's a common connection.
All right. Well, I'll explain it on the next one then. Shh. Y'all listen. All right. So here's our histogram we just made. Okay. Based on the random sample of 30 viewers, what age group would be a good match for products advertised on this TV show? Explain. Now notice, what is my range for all of them?
4.
Somebody said it.
4.
It's not 4. Somebody said it earlier. No. 5. It is 5. Okay? The reason it's 5 is you have to count the one it starts with. So this one, okay? This had 0, 1, 2, 3, or 4 people. Okay? So they're starting at 0, which you have to count. Okay? You don't subtract them. This one, 5, 6, 7, 8, 9. There's 5 of them. All right? So that's why it's like this. Okay? Histograms are usually, the range is 5 between each little section. Okay? So how many people 5 to 9 were watching this particular show? None. Okay? How many 10 to 14? 2. How many 15 to 19? 10. How many 20 to 24? 10. 25 to 29 was 4. 30 to 34 was 3. 35 to 39 was 1. Okay? 40, 44, 45, 49, nobody. Everybody understand how they did the graph? Okay? Where did they get those numbers? From the data they gave us, the list of numbers. Okay? It says, based on the random sample of 30 viewers, what age group would be a good match for products advertised on this TV show? 15 to 24. Again, the book, I don't know why it says 14 to 24, but that's not right. It's 15 to 24. We had how many? 20 different people, 15 to 24. Okay? We're watching this show. So if that's your demographics, that's what I would pick. Okay? Now, the question, it didn't even ask the question, did it? Does everybody understand how to make the histogram? And more importantly, how to read the histogram? Everybody's good? All right. So we got a dot plot, a histogram, and finally a box plot. Okay? Again, information is here. Students at a local high school organized a fundraiser for charity. Caitlin, the student council president, announces that more than half of the students raised over $50 each. The amounts of money raised by a random sample of 24 students is shown. Do the data support Caitlin's claim? All right, so she has this claim, and we're going to make a box plot to see if the claim makes sense. Okay, so she said over 50%, more than half of the students raised over $50 each. So let's see. First off, you need your smallest number and your biggest number. What's the smallest number called? Somebody said? Minimum. And the biggest number is the maximum. What's the middle number called? Median. And then halfway in between those two is the interquartile, the first Q1, right? And then in between the middle and the biggest is Q3, okay? Q2 is the median, okay? That makes sense? All right? So, list the data from least to greatest, okay? It says create a box plot of the data, so that's what this looks like, okay? We write them in order, okay? Halfway is the median. If there's two numbers, so listen, if there's an even number of numbers, you have to do what to the two numbers in the middle? Add them up, divide by 2, okay? Same thing for the third quartile, same thing for the first quartile, all right? So 45 is our halfway, 52 is our third quartile, 32 is our first quartile, all right? Ma'am? You half the halves. So the median is half, then you take, so there was 24, I believe. I may be wrong, but I think there's 24. So I take the first 12, 6, 7, add those up, divide by 2. The last 12, 6, 7, add those up, divide by 2. Okay? That makes sense? Yes, sir. All right. Use the box plot to interpret the data. The box plot shows that based on the sample, the median amount of money collected was $45. Since half of the population collected $45 or less, the data does not support Caitlin's claim. So if half of them made $45 or gave $45 or less, is there a way half of them could give $50 or more? No, it doesn't. That doesn't make sense. Okay? Any questions? Why did it not show? Did I miss the box? Maybe I...
This looks just kind of... You should have heard my dad joke. It was funny.
There it is. There we go. that would be the box plot. Now, some people call this a box and whisker. Okay? These are like the whiskers. The line in the middle is what? The median. There's Q3. There's Q1. Now notice, why does Q1 not look like it's in the middle?
Because it's the middle of the median.
Correct. It's the middle of the middle. Okay? It's the middle of the first half. Q3 is the middle of the second half. Always remember that. Okay? Everybody good?
Wait, say that again?
Q1 is the middle of the first half. Q3 is the middle of the second half. Okay? Again, a lot of this is just making sure you can read. Yay. Hopefully all of you can read. Read the chart. Suppose Caitlin wants to make the statement that 25% of the students, of the 24 students she sampled, raised over a certain amount for the charity. What is that amount? So, how much money did they raise? Or can she say 25% of them raised? How much money?
32.
32.
All right. 32. All right. How many students raised more than 32? 75%. 75% of the students raised $32 or more. I'm wanting which one is 25%. 52. 25% of the students raised $52 or more. Okay? So I want you to understand. Here's half, right? There's 75% going this way or 25% this way. This is 25% of the data, half of the data, 75% of the data, 100% of the data. Does everybody understand that? Q1, that's 25%. Q3 to here is 25%.
Basically each section.
Correct. It's breaking it down into fourths. Okay? So this is the first fourth of the data. The first part of the box is the second fourth of the data. The third part of the box is the third fourth of the data. And the last whisker is the fourth part of the data. Does everybody understand that?
Yes, sir.
All right. Beautiful. Now, let's figure out which one we would pick. So we got 3 to choose from. Dot plot, box plot. What was the other one? Histogram. Okay. Helena's dance team scores 68 points at a competition. For the scores for all of the teams that completed are shown. Helena, I'm not sure how you say it. I know we say it Helena around here. Wants to know what place her team finished. Should Helena use a dot plot, histogram, or box plot to display the data? Which one would be the best way to know how she did? The dot plot, okay? The dot plot, because that way I can look and see how I matched up with everybody else's score, okay? Remember, the histogram, we're talking about a range of scores, right? Okay? The box plot, we're figuring out, are we quarter, half, 3/4, that kind of thing, okay? But if I want to know the exact place I'm in, I'm going to do a dot plot, okay? I'm going to make a dot plot. Boom. They didn't make one. I guess they just used it. I'm not actually going to make the dot plot. I'm just going to use common sense here. We scored how many points? 68. So every person above us is a place, right? So that's not above us. So we're ahead of that person. 1, 2, 3, 4. Oh, nope, that's us. 4, 5, 6, 7, 8, 9, 10, 11. So if there's 11, 12. I thought it was a 61, it's 81. So 12. So there's 12 people ahead of us. So what are we in? 13th place. That's not very good. 13 out of 16. That's not good at all. All right, let's try this one. Helena's dance team scored 68 points at a competition. The scores for all the teams completed are shown, so there they are. What place did Helena's team finish in the competition? Did I not just ask this? Okay. So, hopefully this says 13th, right? Hey, we're good. 13th out of 16. We got it right. Good job. There's the dot plot. They really weren't good. All right. Saying one more question. Which data display should Helena use to know if she wants to, Which data display should Helena use if she wants to know what percent of the team scored higher than her? The box plot. If you want to know percentages wise, you're going to use the box plot. Okay? Everybody understand? Yes. Because that tells me 25, 50, 75, 100%. Everybody good? Awesome. All right. In your book, quick little summary of each one and what they're good for. Okay? Also a summary of what they look like. Basically a histogram. What's it look like? It looks like a bar graph, okay? It's a bar graph. Y'all remember bar graphs? Okay? What makes it a histogram rather than a bar graph, though?
They're connected.
It goes up.
It's got ranges, okay? You used to do you used to do dot plots. Those used to be bar graphs, okay? You just go to 1 or, 1, 2. Those could be bar graphs, but they use dots now. So just understand, what makes that a histogram is it has ranges at the bottom, okay? Let's see talk about some that you were going to do for homework, just real quick.
All of them. I just number 16.
Well, I missed it.
Number 17. The 17 is like, I don't know what that means.
There it is. Okay. For each data set, create the data display that best reveals the answer to the question. Explain your reasoning. Now listen, you only have 16 through 24, which is what, like
10.
that's 9, right?
Yeah,
And then you have 27 and 28. So it's 11 problems on the first page. So and the second page it's only 9. So you have 20 between the 2 pages. Okay, that's not a lot. Understand what they're wanting. They want to. It says 16. What is the median value of the data set? Notice they don't just want you to tell what the median is. They also want you to create the data display. So you have to make the dot plot or the histogram or the box plot. Does everybody follow me? Okay. If they're asking for the median, which one are you going to be making? The box plot, because the box plot uses the median. Everybody good? Okay. 17, what is the frequency of the data? Value 83. If I want to know how many times 83 happens, which one would be the best to use? The dot plot, because that's going to tell me how many dots will be how many times 83 got used. Okay? So make sure you not only you answer the question, make sure you do the data display as well. Okay? The other questions are very similar. 18, how many data values are between 7 and 9? They gave me a range, right? So that's going to be the histogram, okay? How much am I going to count by on the histogram? If I want 7 to 9, 3, okay? So I'll go 0 to 3, or excuse me, not 0 to 3, I'll go 0 to what? 0 to 2, and then 3 to 5, and then 6 to 8, and then you'll be at 7 to 9, okay? Is that making sense? All right, we'll cut it off there. Hope you have a great day. Stay above the line. See you next time.